Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 505 maximum sum of M non-overlapping subarrays 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I want to first say a couple of things about this problem. One is, yes, it takes the alien trick. It goes by the names, whatever. Is this thing where, honestly, if you're seeing this in a contest, and I recognize this immediately, to be honest, but I didn't know it like well enough to be also honest. I just knew the existence of it, and I've never solved this before or like used a trick before or whatever. Second thing is that also honestly, a lot of people has asked me about this. Some of it a little bit spoilery, and I'm fortunate that by the time I got to this, it actually really didn't matter whether I knew it was alien or not because um, like I didn't solve it anyway. But yeah. But I would also say that most of you, honestly, probably 95% of you, if I'm being honest, mostly because, I don't know, you probably, if you want to spend time learning this because you're enjoying this, fine, it's fun. I'm a math nerd, I'm a nerd in general, probably a big nerd, big nerd, right? So I love learning this at some point, and the literature is really hard, right? Or at least like very specific, which is fine, but I just had trouble understanding it the last time I looked it up. And I always just kind of procrastinated, so I never actually did it, right? And I've only seen it once, so this is the second time. It is what it is. But the key thing is, and there's nothing in the algorithm or the idea or the trick that is impossible, but I would also say that probably 95% of you, as I was going to finish my sentence, it doesn't matter. Learn something else. Like if you really want to get better at competitive programming or interviewing, for sure you do not need to know this. I've never learned it, as I said, right? For competitive programming, maybe once every 5 years or something like that, it comes up. Maybe more recently on Leetcode for some reason, but I would also say that, yeah. So if you want to get better or even improve your rating, any of those things, it's probably better to just eat the loss of not getting this and just get better at anything else, literally anything else. Get better at dynamic programming, get better at sorting, get better at greedy problems. Those you actually use a lot more. The reason why Leetcode have problems like this is, well, I don't know the reason per se, but my thought is that when you get problems like this, it just means that the Leetcode problem setter is lazy or whatever, right? And I don't mean this in a, maybe I mean it a little bit in an aggressive way, but I just mean that, it's hard to come up with a good problem. That's one. And it's hard to come up with a good problem that is of the right difficulty, right? That's two. And I don't debate this. This is hard to do. But when you resort to just like this problem, you find essentially being, have you seen this trick before, or have you seen this problem before, then it's not really difficulty, it's just whether have you seen it before. If you've seen it before, you would get it. If you haven't, you don't really. And it's also one of those things where, like, if you're really good, if you're good enough to come up with it, you're probably good enough to have already seen it before, kind of thing, right? That's not always true. I know some like ridiculous geniuses, but you get what I mean, right? Like, the people who are practicing for these things, they would have seen it before, and so it's not a good contest problem if you ask me, right? At least and definitely not within the realms of Leetcode, right? Leetcode or interviewing difficulty is my point. Anyway, so that's a little bit of a rant, and that's a little bit of a disclaimer so that you understand the scope of this problem. And I did not solve it during the contest. In fact, even though I had like 25 minutes left, I was just like, okay. I immediately looked at this. I immediately be like, okay, this is alien problem. I refuse to solve this. And then I just took a nap, right? But I did use this opportunity, because this is actually the first algorithm, and this is maybe a little bit of background. You feel free to fast forward. This is the first algorithm that I was like, oh, maybe I could see the skill, the power of AI. So I had AI walk me through, so now I understand it. And if you watch the live portion, well, the live portion, a lot of it is just me. It's just me not doing it. But after that, I did a session with Quad Code, and I came to understand it. And then from then, I implemented myself without referencing the understanding again. So even though I didn't do understanding, I was able to kind of implement it by myself, which speaks to actually the simplicity of the idea, kind of. I mean, of course, there's a lot of foundational steps that you have to go before this idea is simple, but I don't think the idea is that tricky, and it's kind of cool. Like, I'm not gonna lie, I dig the algorithm, which is why, yeah. And then from that, you could see me live programming it, and there was a couple of ideas that I was not specific on, but I was able to solve it my own way, which honestly led to the final code being bloated and ugly and a lot of weird edge cases that I had to address. But eventually I did get it after an hour and a half, which as a first time implementation off your head, of what you think is the understanding, maybe that'll inspire some of you in that, it's just about understanding the algorithm enough that you're able to implement it from scratch, and that's what I did. Okay, so without further ado, so I will also say that because for these contest videos, I generally just go over the prerequisites, right? And then and I don't go over the prerequisites. I just go over that you need to know these prerequisites, because otherwise, first principle is going to be really tough. The key thing, of course, is that you should know Q3. That's the first prerequisite. Hopefully, it makes sense. And if you're watching from the future and you don't know what Q3 means, then it's maximum sum of M non-overlapping subarrays 1, right? The one that's before this. And the idea there is that you have this. The key thing to be able to do is that you have the first thing is, of course, be good at dynamic programming. And what do I mean by good? At least comfortable enough to come up with the n squared times m solution, right? So this is the first step to DP, and then in Q3 I go over how to convert this to n times m, right? So we get rid of one of the dimensions, and that dimension is technically the LR dimension, right? Okay, so once we're able to do that, of course, for this Q, I don't know why I just noticed there's 6 hints because I've been doing the contest one, but I don't know that it's useful. I mean, this is just like stepping it through. I'm just looking at it for the first time, so it seems like it's just stepping through what the alien algorithm means, which teaches you nothing because the hints are not hints. The hints are just basically learned algorithm, because I don't know. That's what it looks like to me in a very brief glance, right? So like that is not really hints. Anyway, so definitely get to that point, right? And then now I'm gonna go over honestly not super detailed. We'll go over the code and maybe that feels a little bit more detailed, but I want you to kind of learn it. Like it is a prerequisite to just know DP, a lot of DP, and also just read up on WQ. Is it WQS? Right, I think it is. No, I don't know all the names. Yeah, WQS DP, right? And also maybe also known as alien trick for some reason, right? And again, I'm gonna go over hopefully enough for you to implement the way that I did, but yeah, right. So the idea here is that we got, this is getting rid of one of them. So now for here, our goal is to get rid of another dimension, or at least make it easier, which is the m, right? So we want to reduce this to n of O of n log n, right? And the idea here is that yeah, and the idea here is that, okay, let's say we have a we reduce this from an n times m, which is 2-dimensional. We want to reduce this to a 1-dimensional problem, right? We want to convert this so that dp sub I or f sub I, whatever you want to call it, is equal to the best answer. How do I phrase it? The best answer using the suffix num sub I, whatever, right? Just the suffix, right? And this is very standard DP stuff. As I said, I assume that you're very well versed in DP, so I'm not going to go over the DP details, right? But yeah. And remember that, the dimensional part, the old one, you might have ij is equal to the best answer using the suffix num sub I thing with j subarrays left or something, right? Okay, so that's basically with exactly j subarray. I just want to be a bit more precise actually for this one. Okay, right? So then the idea here is that, well, the idea here is that we want to make m selection in total, right? And we want to get rid of, this is my first time explaining this. I forgot to mention this. I do want to do a specific video on the alien trick, so maybe that one will have more detail going the entire progression. But for now, I'm just giving you an idea, right? Okay. So then now, instead of having m or j as a constraint, we turn this into an optimization problem, right? So instead of here now, instead of j, we just change the cost. So we have this thing called lambda, right? So that means that I'm not going to be able to do this very well, but hope you understand. Like I said, it's my first time explaining this, and as my professor used to say, the first time the teacher teaches something, he learns the problem. The second time the teacher teaches it, the student actually learns it, and then the third time no one learns it. But anyway, okay, right? So the idea here is that, we turn it into an optimization problem. We define lambda as the cost of making one subarray, right? And okay, what does that mean? That means that now we can use dp sub I, right? And any time we make a subarray sum, it costs lambda, where it costs lambda, which means that we subtract lambda, right? So then now your code, and hopefully this makes sense so far. I know that I'm asking a lot on the proof. I'll go over what this means in a second, but and this is off my head live. So you can imagine the DP, and if you're strong in DP, this is actually pretty straightforward, right? Maybe you have like something like y and major n, or maybe I'll write it tops down, right? So if index is equal to n, you return 0, maybe, or maybe negative infinity, one of those things. I mean, it doesn't matter, right, for this problem, because I'm not going over this problem specific yet. I'm going over alien trick problem, right? So then now, what does that mean? Here, it's just classic tick, no tick, right? No tick, you just do, best is equal to max, best, f of index plus 1, right? that's not a tick, so if we do tick, then now it's f of index plus well, in this case you make a decision, but and this is based off the Q3, but let's say you have some I, right? And maybe, okay, we'll just write the for loop out, actually, right? In range from L to R, something like this, plus, sum of, I don't know that I like the way I'm explaining it now, actually, but yeah. But this is basically the n square solution that I had before. So it's this, but instead of having the left as a dimension, we just subtract it by lambda, right? Can't tell. And that's it. And what does this mean, right? That means that if we take one subarray, we pay 1 lambda, right? If we take 2 subarray, we pay 2 lambda, right? And so forth. Everything makes sense so far. And so how do we choose lambda? So that it tells us how to do M, right? So basically we're almost, in my mind, encoding the problem in a way such that we're trying to find the lambda such that, we pay M lambda and it's okay. And then, right? Okay, so what are some properties, right? If lambda is small, what does that mean? Well, if lambda is small, let's just say, let's just put, the way that I always work things out is that with lambda small, I just use an actual small number. So for example, if lambda is equal to 0, then you can take as many subarrays as possible, right? And in this case, probably you just take all the positive numbers, right? It's just the sum of the positive numbers, right? If lambda is big, then now, for example, if you pay a lot, then maybe lambda is equal to 1,000,000, right? Then you can take maybe 1 subarray or even 0 subarray, right? Because it's just not even worth it to get it at that point. So these are the kind of the 2 things for now, right? So then now, as you can tell, if you now stretch out what's in the beginning, and so as lambda get bigger from 0, we can take fewer subarrays, right? Subarray. Oh, okay, right? And the other way around, get smaller from a big number, I just say infinity, we can take more subarrays, right? Okay. So that's kind of the idea. There are some other properties that I'm not going to go over in detail. The key idea is concavity, but because then with concavity, then if concavity, you get the derivative, right? Which, I mean, it's discrete, but basically the discrete derivative is going to maximize, right? Let me actually retract that for a second. But then now, so remember that for this problem, maybe I'll go back for a second, hang on. We are trying to find the lambda for which M is equal to, or for which the optimal answer takes M subarrays, right? Remember, that's the goal. So how can we solve this? Well, I mean, it's kind of in the hint, it's binary search. There are some right? Because here, if we want a lambda and and the optimal answer takes fewer subarrays, that means that okay, let me give a more concrete example, right? So let's say we pick a lambda, right? And if the lambda is bigger, or if that lambda gives us the best answer, which requires 2 subarrays, let's just say, okay, let me give a more concrete example, right? So let's say m is equal to, I don't know, 100, right? So then now we pick a lambda. I don't know, it doesn't really matter, but like, you know, I'm just banging a thing, right? We pick a lambda, right? And then now what does this mean? We solve the problem. You know, keep in mind that it's this one, so it's pretty straightforward. I mean, you know, you watch Q3 or the previous thing, you know, we reduce this, so this is actually O of 1 now. Just trust me. If you haven't, then well, maybe you should go back to that video. But this is O of 1, so this is O of n. So then in O of n time, we can run this algorithm, right? And of course, as part of this algorithm, we keep track of the max cost, the minimum count, minimum subarrays, right? So that means that as we keep track of the number of subarrays that we used to build this with the max cost, right? Sorry, not max cost, max sum, right? With this lambda penalty. And so if it requires, or if the best answer gives us more subarrays, or if the best answer requires more subarrays than m, then what happens? That means that, well, that means that the lambda, let me double check this in my mind, sorry. If the answer is more subarrays than m, right, then we want to go down in the subarrays, and that means that we go up in the lambda, right? Because as the lambda gets bigger, then the best answer is going to use fewer subarrays, right? That's the idea, right? If the best answer requires fewer than m subarrays, then if the best answer requires fewer than m subarrays, then well, then the other case happens, right? Then you have more leniency in having more subarrays, so you lower the penalty, the lambda, so that you have more subarrays. And that's kind of the idea behind this one. There is some additional thing about concavity, and that is really just like if you draw the graph, right? Let me draw it out, right? So the idea behind this, and let me bring up the drawing real quick. I mean, I'm doing a little bit of hand wavy here. I just want to give you a taste so that you can understand maybe how other people write it. I mean, for binary search, for this one, we're trying to maximize this, you know, that's the binary search. That's what we're trying to figure out, right? For this one, we have to find the concavity, right? Which means there's something that looks like this, because as the idea here is that, right, so this is lambda, and this is the min count of lambda or whatever. I just see for the, okay, I don't know why I wrote of lambda instead of lambda, but right, and count of lambda is just the number of subarrays you have, which is, you know, and we're trying to find, you know, the one for m, right? And the concavity just means that, well, if you take the derivative, you know, you have basically the thing, and then you could binary search on the derivative, kind of. It's not quite that, but yeah, keep in mind that, of course, yeah, as lambda gets more and more. Oh, I think I drew this the other way around, but did I? Okay, I think I messed up on this one. I drew this the other way around, but yeah, as I think I drew the wrong graph even. Sorry, my bad. Hang on. Like I said, this is going to be a little bit rough because this is the first time I'm doing it. Yeah, but as lambda gets bigger and bigger, this goes to 0, right? And then as it gets higher, then yeah, then this goes to like basically n, right? And you're trying to find out m. You know, this is m somewhere. And that's kind of, you know, we're trying to find out lambda for which this is m, right? So, okay. Let's say and we're able to kind of, you know, use this binary search. You know, if it's here, then we go out, down, go up, right? So this isn't the concretivity part. The concretivity part is that now we're trying to prove you know, that as we have more subsequences, right? So, okay. So maybe the other way is saying that, you know, k is equal to the number of subsequences. I think I used j earlier, right? But number of, not subsequence, I keep saying that, sorry. Subarray, right? And the idea, array, and f of k is just the function with the lambda, right? Or maybe without the lambda. No, yeah, without the lambda, sorry. Wait, did I not, was that not on screen? Did I choose stuff for no reason? Okay. Well, anyway. But anyway, the binary search graph is just a binary search graph. I mean, you know. But basically here you have f of k and k, right? The idea here is that this has to be concave. Oops. At the end, my hand hit my mouse. It's hard to draw, right? And the idea here is just that, yeah, right? The idea here is that as you add more subarrays, not only is this increasing, I mean, it has to be increasing. It cannot decrease. You cannot, like, you add subsequences, you'll never going to get a worse answer because you'll just basically break up negative numbers or something, right? That makes sense for this one. But not only that, it has to give you a smaller benefit as you get higher, right? And the reason is because then now, when we add the lambda function, the lambda is a straight line, right? Because for each k, right? Because so the lambda function, or maybe I shouldn't be teaching this. But yeah, but basically the idea here is that, okay, so for k, this is the cost, right? For example, and this is the lambda times k, right? Because if k is equal to 1, you only pay 1. K is equal to 2, you only pay 2, right? And this is lambda times k, right? The idea here is that now we have this function f of k minus lambda times k, right? And that function, if it is concave, is binary searchable, because then now that function would look like, I don't know how to draw it. But it looks, you know, it's just binary searchable, right? Is my point. I don't know how to draw it because I'm not drawing, yeah, I just want to give you a taste. So this is not a great video. But yeah, so that with that, then now you're binary searching for the optimal answer here, right? Okay. And that's basically it. From this, then now we are able to solve the thing. And I don't know if I put this in the video, so I'll just draw it again. And yeah, and for the lambda, as I said, as lambda gets big, you know, the lambda function looks like this, maybe, and this is count of lambda, right? Meaning for lambda, what is this? And, you know, we have, this is m, just the m line. We want c of lambda is equal to m, and, you know, yeah, and we're trying to find the lambda for which this is the point, right? And that's it. I mean, there are like details and stuff like this, but that's basically the idea, right? So then now, maybe I shouldn't have deleted the other graph. Can I? Okay. Well, let me go back to the other graph, which we'll have to redraw. So then now, we have k and f of k minus lambda times k, right? So how do we get the answer? Well, the answer is that we have this function, which will look, like this. Well, this function looks like this, right? Just regular binary searchable function, right? And then now, as we said, we are trying to get, so the solution that we're trying to find is f of m, right? So then now, if we find the optimal thing here, all we have to do is plug in m, right? So if we plug in m, you get f of m minus lambda, this is terrible, lambda times k, or lambda times m, sorry. And then but we're trying to find this, not this, right? So all you have to do is just add back in lambda times m, and that's it. And that's it. That's kind of the entire idea that I needed to solve this. I'll go over the code, but honestly, I don't know if the code is super interesting. You can watch the live portion to see how it took an hour and a half, so it took a long time. But this is the, yeah, right? Yeah. Yeah, because basically, okay, let's look at this. We have we binary search on lambda, right? And I even have comment to remind myself. We set right to the size of so the biggest suffix array is this. That's basically what this does, because then because if lambda is bigger than it, then you only have one thing anyway, or something like that, right? So it's good if we solve it, the number of count is less than or equal to m. So this is kind of the way that I think about it, and I don't know if it's the right way. Also, this prefix sum, etc. We did it in Q3, so I'm not going into detail. The key thing here is that the tiebreaker, right? So obviously we're trying to optimize the for each index, we're trying to optimize the value. But if it's tied, we want to optimize for fewer count. That way, this allows us to get us the best answer for. Oops. Sum of L, it gives us the best f of L minus lambda times L, right? And yeah, which is the score that we talk about. And we also just want to have the count, right? The fewest count. And the fewest count here just allows the binary search, right? Because otherwise, for this problem, if you draw it out, there are going to be flat parts, right? And this is a very basic binary search thing. If you have flat parts, you want to, either be consistent about returning the min of the flat parts or the max of the flat parts. And which is why for something like this, I write like at least m subarray so that we can go into the right direction. Everything has to match with the binary search, and whether you go to the min or max or whichever, right? But yeah, but otherwise, there is some deck side account. There's some deck side, right? But to reduce it to O of 1, right? Amortized, and yeah, otherwise this is just DP, right? This is getting the max from it. This is the thing, and yeah, I don't know. I don't know if the code is super interesting because I don't know, but I did write it from scratch, so you could watch it live and watch me make a lot of mistake live and watch me try to figure out live. But yeah, at the end, the answer is just the function plus m times the lambda that we have, and that's it. This video is a little bit wonky, of course, but you know, this is my first time teaching it, so hope that makes sense. I might do a photo video later. Let me know in the comments and let me know how you did. Thanks for watching. And yeah, you could watch me, I wouldn't say solve it live, but implement it live after understanding it next. All right, now, I don't know how to do this one. I don't think I do. Wow, 2,000, so many people got Q3. Magic of ChatGPT, I think, but maybe I'm just not good on this one. Okay. Are these actually the same problems? Just want to make sure. Looks same-ish. N is really big now, so it's not DP. Nums of I is smaller. But I think that's just so that things don't overflow, I think. Can I do a binary search? What else can I do? I'm actually surprised so many people got Q3, but I was just slow, to be honest. But still, the 3,000 people, it's not an easy 3,000 people. Okay, so what is the idea here? So this is M left, right? I guess this is the classic alien trick, which I don't know. This is just dumb. I don't know. It's not very okay. Maybe it's time for me to learn. I don't think I've ever done it, to be honest. But I don't know. 3,000 people got this one. You kidding me? Magic of technology. I'm just reading Wikipedia. Yeah, I mean, I think I know how to do this, but yeah, this is definitely not a... Okay, so we have... Okay, so we take out the prefix thing. So we were trying to max over this. Do I know it? I think I have to go back to an n square log n solution first. So then now we do have a thing with a slope now, right? Yeah, well, no, prefix is not strictly increasing though. I think now I remember what I did with the last problem of the alien trick is that I skipped it. I need to maybe I need to learn it. I'm not going to though. I think not today. Yeah, I mean, I it's also just not interesting. I mean, I don't know. It is what it is. I'm both surprised that 3,000 people got this one, and also that anyone got this one at all. But it's also just not. I don't know. And then Leetcode just refused to catch any cheaters because they think that anyone will actually, just because they can prove it that people can solve everything in 3 minutes is ridiculous. I don't even know how to reduce this to n square log n. I mean, this is only n square, right? So it's actually already better than n square log n. But I think this one doesn't lead itself to an n square. Because the idea of the log n is just that now you have this curve, and you're trying to find the maximum point on the curve. But I'm not sure that I know this one. Well, I know how hard it is. I just never learned it. I know of it, and it's not something that I could prove from first principle, which happens from time to time, and also that it is. I only have 16 minutes left. I am going to spend the rest of the time trying to do some reading, so feel free to just hang out. But I don't know. But with negative numbers, I don't know that this is concave. I think that's the part that I'm actually struggling a little bit. It's just that the alien is just. Am I missing something? I mean, the constraints are the same. I mean, the 10 to the 9, I think, is just so that it doesn't overflow long. But at least we got this one, I suppose. Yeah, I don't know how this is concave though. How do you do binary search if it's not concave? I mean, I know that I don't know this one, so I'm just gonna start cheating. I will also, you know, a lot of people ask me, you know, when do you start giving up, right? And on a problem, and I do have a video on this actually. Let me know in the comments if you're curious. But the TLDR is that, well, I mean, for me, I'm giving up only because I know the algorithm, and it's just that I haven't done. I know that I don't know it, so you know. But if you see a problem where you think that you might know it, you know, you should try to do it because you have to order pieces. I don't have the machinery for this one, so that's why I'm looking. I'm looking for someone respectable. Otherwise, I would just ask ChatGPT if I want to ask ChatGPT. Is that you? Yeah, is it, okay, well, I don't have this set up, but I mean, I don't know. I guess if you have it ready. I mean, I guess if you have it ready. But, yeah, maybe I just need to know. I don't think I could, I don't think I could just look at this code and understand it. I mean, there is some like, yeah, I don't know. I didn't know that's how the setup is, which is that you actually binary search on the answer. But I just don't know enough about the alien thing. I just need to work on it. Shout out to Gia, whom, you know, at this point, I hope it's not a cheater. But I mean, he just has a lot of templates. I don't think he needs to cheat on this one to get that score. I mean, like I'm more confident, but you know, I don't know. I mean, TLDR, which I just have to study more. That's all I have for this one. I mean, I'm not even going to finish it out because I'm recording this way early in the morning, and it's just not super interesting to me. I just need to kind of learn a few things about this, and the other thing is that I want to say, right, and the reason why I'm not kind of learning on this problem is that I also understand that there's a progression, right, with a lot of things, a lot of learning things, and this is not. It's probably not the hardest one to learn alien trick on, but it's also not the easiest. So I want to do one where, yeah, I want to do a more, I want to do the progression correctly, right? Otherwise, like, you know, because what I don't want to do and what I want to avoid is just to do it and then end up like not really understanding it, which kills the point. So yeah, and as I said before, I think there was another alien trick Leetcode problem that I didn't solve because I was lazy in the past. I also think this is just like a really dumb thing, right? In the sense that it doesn't really teach you that much more about. I mean, it's just another tool, right? Like it's not like it's one of those things. If you know it, then you use it. Is it interesting? I don't know. But if you don't know it, then you know. Then it's not like you could come up with it. So it's not problem solving in that sense. I mean, it's just problem recognition. But I also could be wrong on this because like I didn't solve it yet. But that's my understanding, which is why I am, you know, going to put this up on later. Okay, let's try to implement this actually. I think I learned how to do it, but it's still sketchy, so we'll figure it out. Would be helpful if I could type correctly, right? Now left is equal to 0, right? Probably, I don't know, big enough, it shouldn't matter, right? And then now if good of mid, so good of mid, lambda is equal to mid, larger lambda means more penalty, which means fewer subarrays. We want to have m subarrays. We want lambda such that we have m subarrays, I think, right? So that means that if this is good, then we want to see if this is good, then now, oh wait, what does this mean? Okay, the good of mid is true if it has at least m subarrays. So then if this is good, then we could try something smaller so that it has m subarrays, something like that. And then maybe return south of mid or something. Okay. And then now we have to do a good function, which is not which is easier said than done. So then now we do the DP, right? Is what they say. I'm trying to think. By the way, I'm implementing it from my understanding that I got. I could be wrong. Maybe easy to miss. Yeah, very easy to make mistakes. So now we have a 1D problem in theory, right? And then now we have for x. Yeah, okay. Yeah, no, for index in range of n, right? So, well, the two-dimensional one is going to be something like y in range of L or +1, and this is the same thing that we wrote before on Q3 is what I mean, right? So dp of index times n, maybe n +1, but whatever. Oh, actually, technically negative infinity. Right? Yeah. And also this is wrong, but because I have to remember the count of it. But let's just write it out for a second, right? So it's equal to max dp of index this will go forwards, because I think this way is a little bit cleaner, maybe not. Okay, so it's equal to max this dp of index, right? So that's kind of the basic, right? And then we have to use the Q trick. Is this plus prefix of index plus I minus index, right? Something like this. Yeah, because you don't include the index plus I. And that's if index plus I is less than equal to n, right? Something like that. Right? Oh no, it's this. So that's the sum. This is yeah, we could do it, then we convert this to 0, and but then this we do I want to convert to 0, so I have to minus the L, right? This part's a little bit tricky actually. How do you get like at least one element? Because maybe you choose to like maybe this is negative, right? And then this is stuff. So I think I have to do like a suffix max. I think that's where I messed up actually. It's +1, right? And then dp of n is equal to 0 maybe. So then if you take one step, then you go there. Maybe. Yeah, okay. Then in that case I don't need this. Maybe. Okay, let's just do it this way for now. I know that this is the n square, but I want to at least to see if this converges, right? Okay, so actually also yeah, this is wrong anyway, because then now is this plus all this stuff versus dp index, which may already have that factor in. I think I messed this up last time too. But then now here, maybe I actually want value is equal to this thing, right? And then now, if value is greater than dp of index, then dp of index is equal to v. But the reason why I want to call this out is because we have to do a thing. Then count of index is equal to count of index plus I plus 1, right? Else, if v is equal to dp of index, then we do min of this, right? I might be way wrong. This is the first time I'm ever implementing it, right? And then now we just return count of 0 is greater than equal to m. Right. I mean, I didn't return anything, so I don't know how that would even have solved it. But actually, I guess we can. Okay, I do need a self ring, right? So yeah, okay, actually, solve for this lambda. Return all of 1. Okay. Someone like this is not quite. I would be ecstatic if that had somehow worked. But also, how come I can't change to the? Okay, there it is. Maybe. Wasn't there like the other view? I don't like this view. There you go. What? Isn't there or am I confused? Isn't there a view where it just tells you the answer? Or is that like only during contest mode? This is so dumb. Ugh. Why is that only a contest mode stuff then? Like there's a different view, right? Okay, well this is lame. But okay. It gives 2. Is 2 even a possible right answer? Maybe, but okay. Oh, I'm not trying to solve mid. Though I guess that should be the last mid anyway. But I mean that should be the same now. But let's see. L dp of 0, count of 0. Okay, dp of 0. I mean this should be big negative, not surprise. Count is 2 arrays. We keep on going lambda smaller. But the thing has not changed, right? So even if the lambda is 0, the value is 2. Why? All right, let's just print out the full dp. It's 2. Okay, so we're going backwards. This is 0. The 2, we choose 2, which makes sense. This one, we choose 2 numbers, which also makes sense. Here, we have 1. And the lambda is 0, right? So here, which probably doesn't make sense, actually. But for 1, we... oh, I didn't do the skip, that's why. Okay, I didn't do the skip. I see. Okay, fine. If dp of index, well, if dp of index plus 1 is greater than dp of index, then dp of index is equal to dp index plus 1, and then count remains the same. Okay, maybe that changes things a little bit. Okay, definitely not, unfortunately. Why? Because this is equal to 0, so it's a little bit awkward. Because then now, well, the best is just choosing none, right? So maybe that's fair. Let's see, does it carry all the way down? Maybe my binary search is wrong, to be honest. Okay, because if the lambda is really big, then the best answer is just choosing none. So if lambda is big, then more penalty, fewer subarrays chosen, right? Okay, so that means that we do want a smaller lambda. So this binary search is right. Now, if I think my has at least m subarrays wrong, because if it's too small, because if it's too small, then we actually want to go lower, right? So that means that if this is true, you actually have to choose no. Okay, so if it's too small, I'm trying to think from first principle, by the way. Like I read it, I went through it once, and now I should understand it, but I don't know that I do. But okay, so if the lambda you would choose none if the lambda is too big, and because the smallest count is 0, then you want a small lambda, right? So maybe I just misunderstood. What's this? Which is possible. Maybe I misunderstood some part of it. Because if it has at least m subarrays, then we want a larger penalty, right? We'll play around with this, but that doesn't make sense to me. And this is now I mean, these numbers are closer. I obviously it's still not right, but well, in that you have to choose at least one, right? So here is choosing 0, which maybe is yeah, maybe that's fine, or not fine, but just that, like, yeah. This is also choosing 1, because this is 0 is the better answer. Okay, right? But this is this right? Okay, what am I printing again? So it's printing, okay, so with lambda is 1, the best answer is 6 with 2 count, right? Which one is this one? The second one? It's 6 with 2? No, this is only 1. Oh, well, no, this is only 1. Well, it should be only 1. Let's print out count as well. Yeah, I mean, when lambda is too big, it just doesn't make sense to make any moves. When lambda is small, okay, so how do you get 3? Am I doing the cost right? So you have -4 minus 1. So that's already -5. Oh no, I'm looking at the wrong example. That's why. Wow, I am just a dumbo. Okay, so you have 4. Okay, so oh, I see. It's because now lambda is 1, but we want to solve it with lambda but without the thing. Okay, so maybe you cannot reuse it. I forgot that. Wait, do you? No, is this? Oh, I think the answer here is r is equal to this, and then now it is r of 0 plus r of 1 times left, or something like this, right? Okay. Wow. I mean, I don't think I am done. I mean, obviously I have to do something about the zeros, but I mean, you know, I'm gonna be not gonna be unhappy about it. I'm 100% confident that I'm not right, but that's okay, right? The reason why this is because there's no 0 array. Right? How do I do that? Okay, so okay, if r of 1 is equal to 0, that means we have to choose at least 1. Then now we try to, how do I solve it? Do I just do it brute force? Is it just Cadenes? Well, it's Cadenes but with L and R, right? So that's a little bit yucky. And also, by the way, I know that I have to optimize this out, but I am going to probably submit it just to see how, if, like, you know, I get wrong answer before that. But yeah, this, I mean, you know, not impossible. I mean, we just use the same deck thing that we did before, right? It's just max over things. But how do I do it with only one, right? Well, I mean, I guess if we're doing n square over it, then we might as well just write for I in range of n, right? For j in range of, yeah. L and R plus 1. I don't know, I'm bragging out. But basically, we just take one subset, right? Prefix of I plus j minus prefix of I, right? So, yeah. So best is equal to negative infinity. And then now here we have best is equal to max best of this. And then we return best. Oh, R is different R. Eh. Love it. Okay, I forgot to do if I plus j is less than n thing, or equal to, actually. Right? Okay. I know that this will time out, but I just want to, it's like a more of a proof of concept because I'm kind of tired to optimize this right now. At least without further whatever. With this times out, we are happy, we are Gucci, and then we'll continue to, and then we'll just optimize, right? Oh, yeah, see, this is what I mean. But I'm actually surprised it went that far. 974 is pretty far. Why is that? Maybe it's a one-digit thing? Or one number thing? So you have two, so we have to pick two numbers. So it's going to be 30 and, or at least two numbers. So, okay, so it's, oh, no, yeah, two numbers. So it's going to be this one and this one. Why do I get 102? Maybe, maybe it's the tie-breaking thing. And okay, that's the result, and lambda left. That's a reasonably sized one. Okay, so then now yeah, okay, but but the binary search seems to fail then, right? Let's see. Okay, so we pick none, and then it's 1 and then 3. That's a really awkward looking binary search. So it goes from, I guess not actually, but so maybe the tiebreaker is wrong. If v is equal to dp, then we minimize the number of things, right? So for 30, so it's, oh, because this lambda is exactly the same as this. I think I also just didn't do else if. Maybe I had to do this. I just noticed that I might have missed a thing. I need more sleep, but okay, unfortunately that's not enough. So 30 is 1, right? So the best answer for lambda 0 to 30 is the answer 1. Then it tries something, whatever. And then now it oh. No, I think this is I think my binary search is just wrong a little bit. It's imprecise. No, that's not my binary search. Because it favors the 3 instead of the 1. It should just take the 1. Right? Because it means that 1 gives the best answer. Even though I don't think it does. Or maybe the way that I wrote it, it does. But okay, where's my binary search? Okay. Okay, so yeah, so I have to, so before, so the last one is, we're close. Last one is 2931. So then we do 30, 31 is too small. So I think I might have to change the signs. Yeah. Okay. So now it favors the 1. But it gives me the wrong answer the other way. How do I get a 2? Because 1 is 42, which is true. Have a look at the DP. I thought we were close, but maybe this is not close. Okay, right. So here, so it's minus 30, so it takes, oh, so 0. That's why. Because it's 0, it takes 0 because, okay. I don't know how to handle the at least one thing correctly, because I thought I had this as 0 would be fine, but because of that, because this is I see that's why. Okay, I think I just need to remove this, and then everything is not fine, but I have 2 more if statements. I'm just going to run it real quick. Okay, that's what I kind of expect. So then now, because the issue is that 0, because the issue is that 0 is a real value, but I also use it as a sentinel value, and it's differentiating it not well. So I think I have to write something like this thing. I think it's, I think I just have to add a new thing. Okay, so you have this, right? But also start a new sequence. I think maybe that's how I do it, right? So this is continue a previous, and then now start a new one, and you start a new one by saying v is equal to this thing, and then that's it. And if you start a new one, then here this is just 1. Otherwise, then if it's exactly equal to for some reason, then 1 is going to be the new min anyway. So, okay. Yeah, let's see. Okay. I mean, at least the other stuff still is right, but maybe it's not that much of a consolation. Okay, so it's not negative 96 after this. 0 after this, okay. 12. So it's this. Oh, because you could. I don't know how to handle the edge case. Because the answer here is that you can get the value 12. You could get the value 12 by just starting a new sequence. And then that would only need one thing. Maybe I'm subtracting out. I know I'm supposed to subtract out the lambda, but I think maybe that's where I am confused how to do it. Because I haven't done it before. I just know that I have to kind of figure out how to subtract out the lambda. And that's how I did it. But maybe that's not quite because I thought that you could just add back in the lambda with the minimum thing and it makes sense. But maybe now that we have it, I mean, can I just change it then to I don't know, a solve version that's maximize this? Maximize the number of counts? Would that make sense? Because for that lambda, I don't know. I mean, this is what happens when you try to solve from first principle, right? So, okay. We'll see. I don't know that this is right, but and then this is just now it's this number, but it can also only go up to m, right? Yeah, I mean, I know that it probably solves that case. I don't know if it's right, but you know, this is part of the learning of, because I think I have the idea down. Now I'm trying to figure out how to do the learning down, right? With all the edge cases, right? Because, you know, this is stuff that we'll face in the future, possibly if we ever run into this thing again. And again, we haven't solved the. Okay, good. Good. I say good because, as I said, we haven't optimized this, right? So this is intentionally, like, I was looking for a wrong answer, because if we have a wrong answer, then yeah, so this is good. So we have because if we have the wrong answer, then something's wrong with the code, right? But if we have TLE, then we can just optimize, and we know how to optimize, kind of. Right. which one do I want to optimize first? This is annoying to optimize though. But we'll do the same thing as we did for Q3. Why is the colors different? It's so weird. Leetcode is so weird. Okay, again though, okay, so we have to optimize this part, right? So we want to get max of dp index sub I plus prefix index plus I. The other two things are constants. So yeah, for I is equal to whatever, right? It's up to here. Okay. So we do the same thing, I think, right? So yeah. If index plus L is less than or equal to N, then we come in, right? So Q dot up. Well, we do the we want to maximize, so we start from the end, and Q of -1 of 1 is, if the value is smaller, then the new thing is going to just come in, right? V is equal to dp index plus L. I guess I already wrote this code, so maybe I could just copy and paste from my old one. Okay, right? So yeah, we could maybe copy and paste this. I don't think it's one-to-one, but yeah, because there's no left plus 1 anymore. V is equal to max this plus this. Does this still make sense? Yeah, maybe. Because this is to start a new one thing, right? Because then now we have to also factor in the count, right? So C is equal to count of index plus L. And now is this, then that's true. But there's also a equal case, right? So N, if this is equal to V, and previous of -1 of 2, if we have less than L, is it? Not L, C, but which one? I'm trying to think which one direction. So if C is bigger, then we remove it now. So if C is greater, then we remove it. Okay, that's fine. And then now we put in index, V, and C, right? Okay, hopefully this is fine for this part. And then we also do the subtraction part. Oh, right. Can't think right now. I mean, I wrote the code, so. Okay, yeah, that's fine. And then now, yeah, we could comment this out. This is not ticking. I think we go also. I'm trying to think whether yeah, I think that's fine. Best is equal to, how did I write it here? Oh, the prefix, the best range or something. Okay, so then now best is equal to okay, so okay, let's just say negative infinity for now. No, in the worst case, the best is equal to, no, maybe negative infinity. Yeah, because it's just maybe not possible. because if none of this is in range, then it is just negative infinity, right? Or well, just this. But otherwise, okay. Yeah, right. Okay, so if this is our range, otherwise if length of I call it previous, but I actually start using Q. That's just what happens when you copy and paste. Okay, right. So if length of Q is greater than 0, then we take it from the start, or possibly take it from the start, right? So if Q of 0 of 1, which is the value, is greater than dp of index, then dp of index is equal to Q, and count of index is equal to 2, right? Okay. Else if they're equal, then we have to update the count, right? Well, we update it if it's better, right? So okay, right? And then there's the starting a new one thing. No, this is starting a new. Is this counting the starting a new one? This number minus prefix of index. But so okay, so this is the max of this value. Well, I need a +1 anyway, so this isn't quite right. This +1. But I think I have to do this here. Okay. I see. So it's right. So if I just write it out, right? Okay. If prefix of index plus L is greater than V, then W is useless. So then V could be index plus L, and C is equal to 1. I think actually even if it's equal to, because then you just don't, you take one fewer thing, give it a spin. I still use preview. Okay. Give it a spin. It's probably not right. Why is it not right? Oh yeah, because we didn't fix it in here. Alright, we already submit this, so it should be fine. We can go back. Oh, this is awkward as heck. It is confusing that now we're trying to get the exact chunks. But max on the count instead, and then now this goes the other way. I think I could be wrong on that actually. Let's give a YOLO 1 self F not found because I've also need to use a restroom at some point. My cube doesn't work. I mean, I probably just missed some stuff, but meh. Really don't want to do this. Especially the debugging. Debugging is so sad. This one, right? And this is just returning something ridiculous. 120D5, and the lambda is probably just really big. So why? Okay, well, I guess we can just print it out. Wah. There's something probably wrong here, clearly. There's a 0 and then there's a 2. How? How is lambda so big? Oh, did I just forget L? Yeah, I think I just forgot L. Okay, so that's why. Yeah, okay. I mean, that makes sense. Because in my translation, I just forgot about L. Okay. I mean, at least more of them are, at least this one's clear. I don't know how you could jump from 0 to 2. I think it's just 0 by default, but how do you get 2? That's actually a smell. Like it always jumps from 0 to 2. Why? This is on the min one, right? Because that's where we have the DP. Did I do a +1 here already? No. Oh, because this is 2. Okay. Alright. So this now is still right. And okay, that's what I was looking for. Did I fix it in both places? Where I have it? Oh, this thing. And this is really annoying. But okay. But now we have to figure out why it is wrong for the code. What are you doing? Okay, fine. Okay. How did this happen? What is this again? So our lambda is 0 for some reason, because 0 allows count to be 2. No, but when you do max version, it gives you 2, right? So it's 2 times 0 times 2, so that's why it's. But then it's just always 1, which also doesn't make sense. The answer should be 0. double count L in places or something. This is a retake one, take one, right? It's not factored into here. This is no tick, right? So this is tick. Okay, well, I mean, this is hard to implement even when you know how to do it. I mean, I don't know if I know how to do it, but like, you know, I had to write that. I mean, I had the n square solution, so I think I'm just messing on the q's, right? So, quite a half victory for now, but we still have to figure it out. These values don't make sense. Oh, maybe it does. It's 2. The Q is wrong, probably. Well, that explains it. Do I not push anything to the Q? Index plus L. Why doesn't this... Do I reuse L and R by accident somewhere? Which happens a lot. No, it's just empty the entire time, right? Okay, I mean, that's easier to fix. So we never go here. Why? Why? Huh? Why is the index so big? Oh, it's output limited, not actually I was just very confused. But okay, fine. Let's take out that case. I mean, yeah. Okay, so the queue does get populated eventually. Put it back in for now. Okay. So index 3, index 4, 4 Q, right? So 4. So then okay, so the deck is I wouldn't say fine, but there's stuff on the deck. It's index 4, the value 2. Okay, so I'm not. Okay. Oh, this is an N. Whoops. Okay. That just never happens because that's a thing, and I didn't even get caught. I mean, this shouldn't be right yet because we didn't fix the other one. Right. Okay, I just fixed the other one then. I don't know. a lot of easy mistakes to make, right? Okay, so that was actually the only mistake, hopefully. Still not good yet though, right? Because we have a lot of print statements. But also, oh, just this one, is it maybe? No, there's another one. This one. This is still too slow because of this part, I think. I'll give it submit again just to kind of save it and let go. It still should time out because of this part, but that's fine. I'm just resting it, and I think I'm if we now get a wrong answer, then we know that this chunk there's a mistake. So I could. Oh, this is much later though. That is annoying. I was actually expecting a TLE, and not this part. Is it on here? Like I want to know where this answers from. Okay, so now this is from the other parts. Can't tell if this is just a pattern. Okay, so 3, so it takes 3 and then 3. Okay, I could see that. Okay, so then what is the... okay, so the answer is C or Y. Doesn't make sense. What's our lambda? Okay, I see. Min did I forget a max in somewhere? Oh, because this part may be different. Maybe? No, I mean that's... So basically, I mean, we could probably just take a subset of this. I don't think... I mean, this is for... yeah, I think this should be fine. We don't need that anymore for now. Because I think this should give me the wrong answer anyway. Like the correct wrong answer, okay. Why is that though? But then now we can print. Oh no, I wanted the other one. Maybe that this one's right though. Who knows anymore? I mean, I wasn't sure about this part of it ever. What is this? Return 0, 1. I see, because this is and then this is for this, right? We have 0 because this is 0, and then 1 sequence, and then the max. No, I mean, the max version is wrong, I think. Did I forget something? Let's take a look at the max version. I think the min version is right. I don't even know if this is the cleanest way to do it. I'm self-learning, right? So, yeah, this is wrong. because one of these something like this. So so this is 0. Oh, okay. So it's this case because I'm maxing incorrectly. So it has to be strictly greater than, because you want the max. Okay. Okay. A lot of subtle things like that. There may be a better way to handle this that I don't know about, and I'll research later. But right now I'm just trying to learn, figure out how to code this from first principles. And again, this may time out because of this case, right? I hope so anyway, because otherwise I'm just very confused. How come it doesn't? No, it doesn't out. Well, there's a standard out. Did I print? Oh, it's this thing. Wait, do I? Maybe I do print other stuff because I think I just left it in though. So I forgot to take that out when I found the bug. That is just me being dumb. Did that output? Okay, maybe I should just submit again. Because I think I just left that in by accident and all the printing is timing it out, which happens. This should still be too slow though, so we'll see. Okay, so it's still the same case that we had, even though locally it was fast enough. As you see. I don't think I could make this any much faster. I probably had to do this. I probably have to optimize. I think this is the case that times out, but like this ends up using too much time or something. So that's probably fair. Right. So maybe I could do best max best max of prefix from I plus j to I, and this is just me being lazy. So we'll see if this actually works out for me. Minus prefix of I, right? We'll keep the 0 thing because it shouldn't come up that much. Let's give it yellow submit. This is a little bit faster. We'll see if that actually does anything. If not, then we'll just do did I miss any n square e things? No, I mean this is all one, so it must be still here, right? This is so annoying. It's not that bad though. If I plus, oh, this j doesn't make sense actually, so maybe that's just wrong. I don't know. I mean, now I'm just messing around anyway, but I'm gonna submit because why not? But we should do the same thing we have here, right? I guess I could just write it out. I don't need to copy and paste it. That is annoying. And if it still times out, I'll just optimize it. If I plus L is oh, because now we're going forwards actually. So yeah, if I plus R is less than n or less than or equal to n, then q dot append I prefix of I plus R if I plus it's very annoying. Okay, so this is the thing, and then if I plus L is N, then Q dot pop or whatever, right? But we have to pre-calculate it. Okay, that's fine, right? Okay, yeah. And last one. Well, this is smaller than prefix of I plus R. Okay, right? Yeah. And then now, yeah, if and then now it is just Q of 0, right? And then now we have to actually start this off with for I in range from L to R, L minus 1 to R maybe, without a pen prefix of I, something like this. Oh, that's not right, because you have to do this thing to it every time. But something like that. Okay. I don't know if this is fast enough. Well, I don't even know if this is right, to be honest. I'm going to YOLO submit. And if it times out, then I have to really look at how to optimize it. Maybe this doesn't come up that much. I don't know. I'm just assuming. Oh, not this. Yeah, this part. But everything else is linear, so unless I'm missing something, I don't think so either. This is just straight up DP, right? And we've been stuck on this for a while. I can't find the submission tab because Leetcode sucks. Yeah, I mean, maybe not that long. I mean, because I think this one was intentional. So we spent about 20 minutes optimizing. That's actually quite a long bit. I mean, I think this is probably right, but I don't know why it's not fast enough. I don't know that there's any way to make it faster. I am going to plug this into ChatGPT to make it faster, but yeah. Let me see. Is there more? I mean, this is pretty linear. So I don't know. I mean, I guess I can set the constraints to be smaller. I have 10 to the 10, which maybe is a little bit nuts. I don't know, right? Like this would make it faster. I guess we'll YOLO submit it. Hopefully this is fast enough. Or just smaller. Okay. M is equal to 1. Does it print 0? I mean, okay. So now at least it's fast enough, but wrong still. And I can't tell if it's just this part. Let's see. No, I guess not. What's the answer here? So 1, we want to use the entire array. I output way too much. Oh, because the thing is too small. That's what I was worried about. But then the other way is too big. How many numbers is this? 5 billion? Still not right. So this is right, but too slow. What is the maximum lambda that I can choose? That's maybe something that's interesting. Like, can we do sum of nums times 10 maybe? Would that be fast enough? Would that be even possible? Well, this is just wrong then, right? So yeah, so maybe max of this and at least some basic number. What was wrong about that one? The lambda is 0, is it? Why is lambda 0? Oh, because we just didn't choose a big enough. Oh, because it's negative. I see actually. Okay, that makes sense. Because sum of nums is negative, or maybe not, but there are negative numbers, so it's small enough. Okay, so maybe try that. So now it's slower because I guess for this one it does even more. Maybe I cap it by 10 to the 10. Which is the old one anyway. I'm hoping that this would give me fewer iterations. I mean, it doesn't seem that much faster, but I'm gonna YOLO submit. I don't know how to make this faster. Yeah, okay. How do I make the? I mean, I don't know how, because I don't know. It doesn't seem like this changes anything. I don't think I can change anything else here. So I mean, at some point, maybe this is a Python thing, which is really annoying. Like, I'm looking at the code, just trying to see how I can optimize fit. I mean, unless I just do like a special case, like if m is equal to 1 or something, right? That just seems sketch. Okay, at least we know that this code doesn't work, and apparently maybe it just never gets caught. But deck index of y. I'm too tired for this, but you want I mean, this is wrong anyway, right? But I don't know. I have prefix of I here, but fine. I just put it out. Probably can be output limit exceeded or something, but okay. So there's this. Then why is it? Oh, because then it goes out bounds. So then, okay, I see. I'm just dumb. I for some reason I thought that can be possible, but I am just dumb. No. Oh, because this is m is equal to 1. That's actually interesting that this is well. I don't know why this thing is so bad. This interface is so bad. Okay, so we have 1, you have at least 2 or 3. We want these 2. It might time out because of the other one, but okay. Okay, so 6 and 2. Prefix is 6. Okay, fine. Okay, where are you getting 7 from? Prefix of I, so okay, you have 6 minus -1, so you have this minus this to get 1 element. Is that right? No. Okay, so on 0 you have 6 and 2. That's right. On 1 you have 6. No. This is 2, right? Did I append them in the wrong way? This is pop left. No, this is pop left. I am dumb. It's slow because of all the print statements on the big case. Maybe it's slow anyway, but all right, let's YOLO submit at least. Is this faster? Oof. How is that possible? Think 111. Why am I so bad at this? Why is Leetcode so bad at this? Forgot to put in the taste. Okay, let's putting this. Oh yeah, so that means this never gets caught. But why not? So prefix is 1. There's a very stupid case I'm handling. Okay, so it puts nothing in, which doesn't seem right. Oh, wow, no, that's intentional. So then now on 0, this push things in, right? Yeah. Okay, and that, but then now 0 plus 1 minus 1 is 0. Oh. Because this prefix has a sentinel 0, and that matches. That checks. Maybe this is going to be wrong in some mysterious ways. Hopefully not timeout though. If it times out now, I think I am going to just ask it to. Okay. I mean, yeah, I mean, I wasn't confident about this one because of negative numbers like this. I think that what I should have done is the same thing that I've done before, but I was just lazy, which is, yeah, add an index. I thought I could get away with it. I mean, this isn't that important in the grand scheme of me trying to solve it, but basically now I can just write if mess something up? It's possible. Who knows anymore? Okay, 0111. Oh, I made the same mistake on the other part, on Q3, I think, or whatever it was. I am such a silly boy. I still print a lot of cases. I mean, I only print like 1,000 lines. I don't think it matters. So maybe I should get rid of it. Again, if it doesn't work, I'm going to use C++. Okay. I'm happy though that I got it. Apparently no one does it in Python, basically. Yeah. Okay. Yeah, I mean, that's all I have for, I know that I'm taping this and then we're going to connect stuff together, but I'm going to do the explanation later, though you probably watched it, not whatever. Okay. Just me trying. It's still, so me understanding it, but of course not 100% understanding it, still took me an hour and a half to kind of solve this, so I don't know. Is it good? Is it happy? I don't know. I mean, I like the algorithm. It's actually pretty cute, but as you can tell, I don't think I'm confident enough to be able to do this very quickly. And I don't know how to kind of, because this is a lot of code to copy and paste, and this solve one thing is a little bit awkward, maybe. Maybe I could figure out how to get away from it. But yeah, that's what I have for today. That's what I have for now. That's what I have for this problem. Let me know what you think. I'll probably just record everything. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.